So this is numbers 14 through 17. In this one, we want to fill out our frequency table before we can get too far. It says, in a survey of 450 people, 200 of whom are female, it was found that 225 preferred chocolate ice cream, including 99 males. So I've got 99 males that prefer chocolate ice cream, so I can use a calculator to then figure out how many females does that leave, because if I have 225 that like chocolate, 225 minus this 99 leaves me with 126 females here. Now let's look. I've got 200 females, and I've already used 126 of them. So 200 minus this 126 gives me 74. Because if I did 74 plus 126, there's my 200 females. If I did 99 plus 126, there's my 225 people that like chocolate. Well, what does that leave me with? Oh, look here. I can figure out how many total males I have because I've used 200 females. So 450 minus that 200 leaves me with 250 males. But I've only counted 99 of them, so how many like vanilla? 250 minus 99 gives me 151. So when you do these tables, you kind of want to work backwards to start subtracting and to start figuring out the missing information. If we did 151 plus 74, that gives me 225 people that like vanilla, and so I can kind of fill out this frequency table. Now let's start into the questions. It says, what's the probability that the person likes chocolate? There's no extra conjunctions or any words, so this is just straight up probability. How many people like chocolate? Well, we found that 99 plus 126 people like chocolate, or 225 people like chocolate. Out of how many total? Well, our total is 450. If we simplify that, that's 1/2. Find the probability that the person likes vanilla, given, there's that given word, that they are male. So we've got the word given, here it is. So we want to see what is given, and that's what we're going to circle to find our probability. So given they are male, let's find our males. Here they are. So that's what we're circling. So now let's find the probability that the person likes vanilla from inside my circle. Well, I have 151 people that like vanilla. Out of how many total here? Well, out of 250 total. So I've got 151 out of 250. Find the probability that the person likes vanilla or is female. So we're looking for the word or. Here it is. So we want to decide, are the events mutually exclusive, or are there outcomes that are going to overlap? We're going to add the probabilities, but if it overlaps, we need to subtract out the overlap. So find the probability that the person likes vanilla. Well, I have 225 people that like vanilla out of 450. Or females. I've got 200 females out of 450 people. Now, do I have any overlap? Did I count any females that actually like vanilla? Yes, I did. How many of those? Females that like vanilla is 74. I need to subtract that overlap out. And so I'm going to add all this stuff together and simplify, and what I'm going to get is 351 over 450. And finally, find the probability, this one says, all being male and liking chocolate independent events. So we're trying to find out if the probability of male and liking chocolate are independent. So we want to know if this is going to be true. So let's go ahead and find out. What's the intersection of the males that like chocolate? Well, how many males do I got? I got 99 males out of a total of 450 that like chocolate. So the 99 males out of a total from 450 that will like chocolate. We want to know, does that equal the probability of being a male? So how many males do I got? Well, I got 250 males out of 450 people. Times, what's the probability of liking chocolates? Well, there's 225 out of 450. And you know what? When I multiply straight across, I am not going to get 99 out of 450. Let's see what we get. 250 over 450 times 225 out of 450. And I'm going to get 5/18. And let's see. This 99 out of 450 simplifies to be 11/50ths. Are these two equal? Absolutely not. So they are not independent events.